Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so what do? We check what is currently approved. Yeah. Let's see. Okay, it's a few things. So what about this one? Okay, there's still some to-dos to do. So what about these spelling error fixes now? Maybe we revisit this. Okay, I will first merge this one and then this one. And then we look over these here one more time. So move particle system, particle editor files to core. Blah, blah, blah. Blah, blah. Okay, this should be fair enough. Okay. Confirm. Sorry. Delete. Okay. And fix radar pixel color format. I think here I had one more comment. Yeah. Let me change to the branch. Fix radar draw pixel. Fix radar draw pixel. There we go. So here maybe we want to rename this to oh boy, it's slow. ARGB color. ARGB color. Good color. Rename color names to. I push that. Then the next, we wait for this to build. Did that. Good. Then let me look at those spelling error fixes again. So 1, 2, 3. There we go. So we have generals MD, and this. Okay, so let's put them side by side here. So what do we see here? Generals include source, include and source. Okay, and here we have also include and source. Okay. Okay. Property chosen. Property chosen. Okay. Okay, include source. Okay, so they kind of match, at least from the folders they touch. They touch vastly different amounts of files though. This one 106 and this one 69 only. And this one 85 and this one is in core and in generals. Why is this in core and in generals? That I don't understand. This change, this pull contains edits to generals code, game engine include. Wouldn't that fit better into this one? Into which also touches this section, this portion. Okay, and then let me ask why does this change? Why does this pull touch code in generals? Why does this pull touch? Why does this pull touches? Why does this pull touch code in generals when there is no other pull that touches equivalent files for equivalent files for 0 hour? Yeah, okay, so I don't understand. This seems fine. Yeah, it's touching stuff in generals, touching stuff in 0 hour. Okay, fair enough. But then we have this change, which is touching generals game engine include, which also this other change does, this one here. So why are these not combined? And then why are here changes to generals, which there's no equivalent for 0 hour? I don't understand. Something is missing here. Either some communication or some actual changes. Incomplete. So yeah, we need to wait and hear what's going on there. I don't understand. Good. Then we wait for this to build and then we merge it. In the meantime, we also wait for this one here. These at the bottom here, they need more work. Good. Let me see. Author. Let's see if Cabal has anything we need to look at. Yeah. Maybe not. Take a look at Mauler. Hide the custom overlay during video playback. Last month, I think that he wanted to work on these things more. Stobiax, let's look at him. Lots of no read. Everything is no retail. Mm. Prevent dead units. Okay. Mm-hmm. Start. Okay, let me take a look at this guy here. I will be focusing on this again. Probably we need a separate refactor. Okay. Okay, and what about this one? Mm. 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 Okay. I've had this on my to-do list for a while. My only hesitation in the existing violation of the single responsibility principle. The function name is location clear object suggests that's a query function that checks state. Yes, fair enough. Yet it also comes with a side effect of modifying. True. Mm-hmm. Better approach would be to move all instances from these functions to the respective call sites. Mm-hmm. Mm-hmm. That is a very valid concern, and I agree that this ideally was a const function and modified no states. Mm-hmm. Mm-hmm. Makes sense. Okay. Mm-hmm. So, anything else we can look at? Let's take a look at this guy here. This change prevents the game from getting stuck showing the insert CD dialog during the splash screen initialization phase. While testing the executable from a non-standard install location outside the usual Windows install without expected registry setup, the game repeatedly prompted for the CD. The goal here is to improve portability and make development testing setups. Okay, makes sense. Yeah, they shouldn't prompt CD. The game can start without requiring a physical CD prompt in scenarios where registry-driven install detection is not available. Portable installs, custom directories, blah, blah. This is intentional and minimal target change, focus on removing the blocking dialog during setup without altering broader CD check logic elsewhere. Okay, it reads reasonable. Let's see. All music files now available locally. No need to prompt for CD. Insert CD. Displays a warning. Game audio. Unload any files from CD first. if not headless, and not is music already loaded. Music playing from CD, true. Oh boy, I shouldn't have clicked that button. Oh boy. Let's refresh the page. So Greptile is happy with this. I wonder if it would be better to introduce a preprocessor directive if one does not already exist for toggling CD logic. Always on fix. We still try and load music files from CD first, but we avoid a system modal infinite insert CD prompt when it fails. If not defined RTS debug. Init. Okay, so audio manager init. If not music already loaded, music playing from CD, true. While true, the file system load music files from CD. We loop infinitely on the splash screen if we don't allow breaking out of this loop. Infinitely on the splash screen. Well, that's a bit. I mean, so this comment. But I mean, we'll always break now. So. Okay, so this comment is obsolete. This whole check is obsolete because essentially what it does is, if loaded, break, otherwise break. So it just breaks. So this whole loop can be removed, and it just needs to set this and then call this. That's it. Everything else here can be removed. All the other junk, the while loop. Unload any files from CD first. Load music files from CD. Insert CD prompt. Insert CD prompt. How about we? What happens? What happens after this? Does the game run without music? Let me ask here. What happens after this? Does the game run without music? How about we display the warning box exactly once and then proceed with the game if it works. Insert the message. Display. How about we keep display the warning box, but break when pressing the cancel button. So user can still insert CD, but can also decide to continue. But break out when pressing the cancel button of the see and click OK, but can also decide to cancel and continue without the CD. That would be my intuition here. There must be a reason that this exists. So basically it doesn't have music loaded. The music files would be on the CD. You put it in the CD, you click on OK button and it loads from the CD. Otherwise, if it cannot load, then the message box comes again. And then if you decide, okay, it doesn't load the music, I don't have a CD, whatever, you click on cancel, boom. And then you're in action. Yeah. So the way I understand it right now, you cannot escape this. We loop infinitely if we don't allow breaking out of this loop. Ah, it does have cancel here. It does have cancel. It's already correct the way I expected it to be. Okay, then never mind my questions. Never mind my suggestion. It already does it. Why can we not delete it? There we go. Yeah. So it already does the canceling. Then I'm also inclined to say that this is fine. Yeah, let's the EA, the way EA has set this up does make sense. Are there more CD related tests like this in the game? I'm inclined to use this. This makes sense in principle. Good. Then this one is also ready. So let's merge this one. Fix radar picks a color format for non-blur surfaces. Okay. Good. Then with this junk fixed, let's go to Git, go to main branch, pull rebase, and fetch and prune. Fetch and prune. Good, then we can delete this shit here. And this shit. And then... Good. The next step, we do a... we can now start creating changes for these two particle optimizations we did. Let me see. I think we can also delete this one here. Yeah. Yeah, so we can delete this branch here. And this branch, do we check? Yeah. We merged all this. Yeah. I think we did, yeah. Let's delete that. Then we have this. I think this one we also all merged. Yeah. Yeah, I think we can delete that. And then here, optimize particle system. Yeah. So then we have this guy and this guy. What is this here? Let's destroy it. Okay, we don't care for this right now. So this can be one change. This guy. Yeah. Let me see. And then this guy. So here we cache length A, length B. If not length. If length. Return 0. Yeah, so basically we save here on 1, 2, 2 square roots. Yeah. I wonder if we should write this here a little bit nicer. Let me go here and do a cherry pick. Delete it. Oh boy. Okay, how do we solve this? Let me cancel. Oh shit, how do we cancel now the merge? God damn it. Just revert. Reset. Yeah. Let me do a copy of this. Create branch 2. Yeah. And then we rebase this onto main after we have pulled main, which we already did. Okay. Okay, then we go here. Then we do a rebase. And then we see what happens. Oh boy. Ah, shit. It doesn't figure out that we moved this to core. Oh, that's a shame. Base file, delete file. Okay, so so we lost a change in particle sys.header for some reason. Maybe we can manually repair it. So we search for this guy. Okay, we first need to generate. Reload all. Oh boy. So, what do we have here? Blah, blah, blah. Yeah. Oh, man. So we copy this bullshit here. And we put it, where is it? Hash. What? What am I looking at here? 7 to 5. 7 to okay, it's up here. Yeah, okay. So this guy, and then this one down here. Then we put this here. Template map, system map. System map. How about we call it system ID system ID particular system ID to I wonder what a good name for this is. Because system map is really non-descriptive. It would be better to name it something like, I don't know. Particle system ID map. Particle system ID map. Maybe we call it like that. Yeah, let's do it like that. Okay, I think that's okay. Good. Let's see if that builds. And then we would go here. And we would do a fix up commit for this guy. And then what? Okay, so that succeeded. Particle system ID map. Find particle system, blah blah. Find system map. Particle system by ID. So how many places are there that actually call this? So these things we added here, and then there's beacon, update, active body. Get this particle. Okay, that's on delete. Kill running. Particle system, my particle system ID. That is on update, yeah. Okay, so there are some on update, yeah. So these could be potentially expensive. Init laser. Laser updates. Okay, so I wonder if it's worth it to measure this. Maybe. Probably not worth it, the effort. There will be some benefit to it, but how much, I don't know. Yeah. The only cost that we add now is that every time we add a template, add a particle effect, create a particle effect, it also needs to add this to the map, which it does. Where does it do that? I thought it would need to do it here. Find, add particle system. Ah, there we go. Erase system ID. Erase. Particle system. Okay, is there any other place where we add something to this list here? Let me see. No, okay, good. Then, yeah, this looks solid. Okay, what I would say we do, we look at laser, some lasers. And we look at some lasers and and the beacon. Why not? Yeah. Let's build. So let's get a USA guy. Let's just get the test map. This one. USA enemy. Random. Yeah. Good, so we're looking for some lasers. Let's take the laser tank. Yeah. Yeah, there's a laser. Let's look at the Avenger. There's a laser. Let's shoot them some helicopters. Yeah. Okay. Then we look at the particle when that is ready. What else did we have? Firestorm. Firestorm. Okay, let's get some mix and create a firestorm. when the planes just launched, that looked really awful. Clip into each other. Is that normal? Okay, let's trigger a firestorm. Shoot here. Yeah. There's a firestorm. Okay. Let's use a particle cannon here. There's also a particle. Okay. Okay, I think that works. Yeah. Okay, great. Then I would say we are optimize particle system, search with hash map. Yep. Okay. Yeah, so my only hope is that it's not too expensive what we're doing here. In regards to adding those particles, there will be some cost overhead, but I think it makes the lookups more stable, which will be relevant for these guys later. Good, then I will say we first do a rebase. Rebase with squash. And then particle system to add, erase. Let me double check that. Let me see, find particle system. Particle system. Hold on a minute. Delete instance. Particle system count. We should probably also have a debug assert crash for this guy here, and say dot size equals 0. Some size is ZU, not 0. What? Improperly terminated macro invocation. What does that mean? Huh? There we go. Okay. So let me double check that. Let's put a breakpoint in here. Um, close this duplicates. This is fixed in the patch repository alongside all other conflicts. Game patch. This one. The patch repository. Okay, so blah blah blah. Let's run this one more time. I would like to see that it's properly cleaned up and everything. Yeah, just double check. So we put a breakpoint in here, and then we trigger a bunch of particle effects by just attacking here one spot. Yeah. Let me put a breakpoint here. It is called, yeah. System map is, oh, it's pretty big. 558 matches this number. Oh, it gets pretty big. 558. Wow. That's pretty big. Okay, let's shoot a bunch of particles. Okay, it looks like not everything is attacking here. Let's do a mass attack. Oh, it's lagging so hard. Holy shit. Holy shit. Okay, let's put a breakpoint. So we now have 813. 813. Okay, how about we make a diagnostic here? Record CPU profile. I would like to see if any of these are ever showing up in there, just as a safety measure. It's really slow. We have 16 frames per second. It's really not much. (13 FPS). Ah. So slow. Hmm. 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 Okay, let's see. Let's pause this. So how do we see our costs? Select the time range. Okay, let's select something here. What was disabled? What does that mean? Huh? Didn't we just have it running? What is this? Ah, here. Okay. Here we go. Mm-hmm. So who are our... What is our main cost here? Kernel. Wasn't there a way to see categories, threads? Right, call tree, functions, flame graph. Generating flame graph. Yes, please. Show me the flame graph. So what is the most expensive shit? Particles is expensive here. Pathfinder. Okay, game logic update, we don't care. Okay, so logic takes this, game client update this. And here we have render, do particles. Particle. Okay, let's zoom in here. We can figure out how. Like this, I guess. No? How do we zoom in there? I don't know. Well, that doesn't work. I don't know how to zoom here. Like, there's no control to zoom. Okay, that works. So, do particles. That's something else. No, that's something else. How do we go back? Okay, I don't understand how to navigate this flame graph. Reset dome. Yeah, I don't understand here. Let's go for functions. Let's search for... Where is it? Oh, particle sys. Filter. What? Particle sys. In core, please. Hä? Oh, man. Okay, looks like this is outdated here. Okay, I have troubles. I think it's add particle system, this one. Okay, so that one is really tiny here, is immeasurable. And let's search for everything particle manager. Particle system. Why is the search so small? Why is this not bigger? What is this? Oh man. Oh, it's implemented so poorly. Oh, what is this? I can't type in here. Why is this so bugged? What is this? Let's try this. Okay, let's order by function name. There we go. Okay, so let's make this larger. Okay, so we have add particle, blah, blah. Remove particle system. Okay, so that has some cost. Update. What about find? Yeah, it looks pretty cheap here. So removing a particle is actually the biggest cost of all. Why? Let me take a screenshot of this just so that we have some numbers. Yeah. We should probably include the top header there. So this. Let's put that in my paint. Okay, so we have something to look at. So update, of course, is pretty expensive, but still like 24. So find particle system 012. It's more expensive than add particle, but remove particle is twice as expensive. Well, I mean, it's called more often. Yeah. Okay, but if we just judge by yeah, I mean, we don't know how often it was called. It doesn't show like how often it was sampled, right? Maybe it's just that the fine particle system is not called that much. It is interesting that remove particle system is more expensive than add particle system. I would have expected that they are more on par. Let's search for remove particle system. Why is that more expensive? So it does a find here. Oh, yeah. Yeah, it has to be more expensive because of this find here. It's a list, right? It's a list. Yeah, so removing, oh yeah. Oh, I see. Yeah, anything that involves walking this is expensive. Okay, I wonder if we can make a comparison somehow. Measurement. How about we do the following? So first we do fix up commits. Yeah. Then I mean, it will cost us so much time now to measure this shit. It would be nice to get some numbers. So let's say we do the old way. So the old way is this. Find particle system. So this is if this is the old one, else the new one, yeah? Okay. So this is the old, and there we have all this shit. Okay, blah, blah. Okay. Here it does complain, though. Right. We remove this. And this. Okay. Okay, I think it should be like that. Without this here. Okay, so this was what it was before. And then... yeah. I don't think we need to measure the other functions. We just do this one. So let's do like a size t count 0, size t max count. Let's do, I don't know, 10,000 searches or so. And then we do get tick count. Get tick count 64. Returns integer 64, right? No. And 64 tick. And then down here we do, why does it return shit? Okay, you long, yeah, okay. So tick, and then down here we do you long time taken equals this minus tick. So this is milliseconds. But this is a very low resolution. Right. Let's go to frame rate limit. So we're looking at this here. Elapsed seconds, time taken. So So we take this. And then we do. Okay, we remove this. And then we do this. There we go. Good. So this one, quad part, what is this referred to? Long, 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 and then long, long, blah, blah. Okay, and that's elapsed seconds. Then here we say double, elapsed seconds, 0, 0, and then let's do like S. Then we say if count smaller than max count, so plus plus max count, then we do this plus equal that. Okay. S max count. So we say here S count, S max count. There we go. We can just say here 10,000. So we do 10,000 samples. Ah, shit. 10,000. You can also just move it in here and make it static. There we go. 11 seconds, and that should work. Okay, so now it will. 10,000 maybe is a bit much. Oof. Let's see, we need to run the game once to see. So this is now the classic lookup, yeah. Classic lookup time. Okay, let me put a breakpoint here again, yeah. So. 0, 0, 0. Okay, that looks good. So let me see. Let me see if this counts up or not. Find particle. There we go. Then let's put a breakpoint here. And let's see if that counts up. We need a laser, I think. Oh, it's not triggering. How do we trigger this shit? Oh, it is being called. Just as we placed it. Ah, it doesn't get there because there's a return before that. Ah, that's stupid. Okay, let's move. That explains it. Right. Okay, I totally missed that. So system. Here we do a break. And the system. And the system equals that. And then return system down here. Okay. Will this work? Break. Break. Okay, I think that will work. Let's see. Yeah, I totally missed that. If we return early, we won't measure. No. See, that's another disadvantage of the early return. I always advocate for this. Don't put early returns in the middle of a function, because then you can't do certain things like this performance measurement, where you can't do with a RAII helper. You can still do it, of course, but not like this, like the stupid way I did it here. Yeah. Maybe we should add a utility somewhere to help this. Maybe there already is. Maybe this is something we should look into. Okay, so it's definitely called. Yeah. Let's see how often. Oh, it gets called very often. Okay, cool. Then how about we raise that number a little bit to, I don't know, 10,000, and then we put an else here, and we say if we 100,000, and if we hit that number, then we do a printf. Yeah, and then we put a breakpoint here. So if we hit this limit, yeah, then we are golden. Okay. Yeah. Okay. So it actually gets called more often than I thought it would be. Interesting. I thought it was called more sparingly. Yeah. Mm-hmm. Mm-hmm. Interesting. Interesting. Mm-hmm. Mm-hmm. Good. So we just wait a little bit and just let it spam those function calls. Yeah. So we have a breakpoint in here, which should hit at some point. Yeah, with a little bit of patience, but we're testing right now in debug, which is not optimal. Maybe we should test this in there we go. So what happens? Elapsed seconds. 4.5 seconds in debug. 100,000 iterations take 4.5 seconds. Okay, that's quite significant. 720. Yeah. Okay, then what I would say we do now is we actually compile it in release. Yeah. Mm-hmm. And we also start without the shell map, and then we just load into this test map where we have all the various objects in there. So I think 700 objects is quite good. Yeah. Mm-hmm. Create Debris object. What is this? Oof. Call stack. Do stuff to object. Why do they call it like that? Do stuff to object. What is this function naming? Generic object creation nugget, do stuff to object. Beautiful. Mm-hmm. Mm-hmm. Okay, but I can already tell 100,000 iterations. It took us, I don't know, 20, 30 seconds or so of playtime. and it costs 4.5 seconds. That's a lot. Okay, but that was debug. Let's test it in release. Yeah. It is expensive, yeah. Maybe it's more expensive than I anticipated. Yeah, it has to go through a list, so that's expensive. And if it's at the end of the list, oh boy. And so the more particles you have in there, the worse it becomes. Okay, so we have done that. Then let's do an install. And then we run this bad boy. I wanted to start without the share map. Let's do that. Debugging minus quick start. Okay, let's go. Okay, but it's still loaded. What the hell? What is that? Why is minus quick start not working anymore? Ah, it's debug. Minus win, minus quick start. There we go. Okay, then we go straight to skill mesh. We load this map, and then we just idle and wait. Okay, we have 144 FPS. We wait. Okay, nothing is happening. Okay, is it actually counting or not? It is. We can't see the number. Okay, well now we have messed up the results. Okay, it's too bad that we can't see this value here. Okay, let's restart. Maybe we need to scroll to all the units. Yeah, it really took much longer than it did before. Right. Let's scroll to the units on the side. Yeah. So let's just click on this icon here, yeah. The second from the bottom here. And then we just look at this place and we wait. Ah, there we go. Okay. So elapsed seconds, 0.87. Okay, so that is a lot quicker than what we measured in debug. Okay. That's fair. 0.087 seconds. Okay, let's write that down. Notepad 0.0. It's nice that we can see this pop up through the notepad. Yeah, Windows is so bugged, it actually helps us. I don't know why we are writing into this file here. Let me open this again. Notepad. What was it? 0.0.087 seconds. Or 87 milliseconds. 10,000 iterations before, after. Okay, so that is before in release. Then let's do a switcheroo. Maybe we shouldn't accumulate a double. It's quite a bit imprecise, but okay. It's probably good enough. Okay, so we load a skirmish and we do the same here. We click on this and then we wait. Okay. And that takes 0.18. So that is 18 milliseconds. 10,000 iterations equals 18 milliseconds. So effectively, that is a performance improvement of 18 divided by 87, 80%. 80%. Okay, cool. 80%, we have it measured. Blah, blah, okay. It's interesting that in release it's so much faster than it is in debug. I mean, the speed was just outrageous in debug. Like, we measured 4.5 seconds here. So that was crazy. Yeah. Interesting. Good. Let me double check the value. Yeah. Okay, cool. Then that is fine. Then good. So we have a result. It's faster. That's fine. Okay. Good. Then I will reset this. Okay. Rebase. Auto squash. Good. Then we go to main branch. And we create a new branch and we say perf particle sys find. Particle sys find. Some search. Then we do a cherry pick. And then we create another branch. Perf particle sys angle between, I think was the name of it, angle between. And there we do this one. Check out this commit. No, not check out. Cherry pick. Cherry pick. And there we go. Good. And then optimize angle between. Optimize particle system search. Particle system search. Revert. Optimize particle system search with system search. Good. Then let's make a push. Hold on. How about we say, how about reduce costs of particle system search with hash map by 80%. Reduce cost of particle system search with hash map. Okay, good. Then let's push that. Push. Good. Then we go here. And then reduce costs. This change reduces the costs of particle system search as a hash map. Particle search with a hash map. Maybe we should say reduce cost of particle system search by 80%. I think it's fine with hash map. 80%. Tested in release. It reduced the costs by around 80%. How about we give it the extra function name? Reduce costs. This one. Reduce costs. Reduce cost of. How about we just say this? Reduce cost of this by 80%. Map instead of linear search through the STD list. Tested in release. Reduce the cost by around 80%. Tested in a release with 10,000 iterations on big test map. original. So those iterations took, measured, original, and this change. 1,000 iterations measured at in debug builds, in unoptimized builds, the performance gain will be even larger. Build the performance gain. Okay, so this is a performance. I would say though that is rather minor. Yeah, minor performance gens at age and milestone. Do we still care for this image here? Yeah, I can say something about this. Maybe we add some red marker here. So the functions of interest are this one, and this one. Well, that looks kind of shitty. Let's redo this. So this one, this, and this. Let's take these guys. Let's remove this here again. Out of remove, add, remove, and find. Remove out of friend, add particle system, add particle system, remove particle system, and find particle system. The remove particle system shows to be the most expensive because it still has a std list search in it naturally. But this was tested in debug. Image from debug test. From test in unoptimized builds. I can't type. Okay. It was not 10,000 iterations, it was 100,000. On a big test map, which takes around, I don't know, 30 seconds to hit. Which took around 30 seconds to hit. The costs was reduced by around 80% in the test. The particle system count was around 700. Was moderate, around 700. The particle system count was moderate. Okay, maybe here we should say comma. Let's do it like this. That's a C++ way. Okay, I think that's fine. I think I spent way too much time measuring, but okay. Better complete than incomplete, right? Good, so that's that. And then the other one, for the other one, we don't care about the measurement. It will be too small to really care for it. But regarding this one, maybe we should write this differently here. If not, let's keep it like that. Let's keep it. Optimize angle between. This change optimizes the angle between function a bit to square roots, to redundant square roots. Square roots are removed. Performance minor gen ZH. Used by the particle system. It is used by the particle system. Bit by removing two redundant square roots. Actually, let me take a look at this. What exactly is in there? Length. It does square root, multiplication, and addition. Yeah. By removing two redundant square roots, by removing 2 times redundant, 2 redundant square roots, 2 square roots, 4 multiplications, 2 additions, square roots, 2 additions, redundant, a bit, change optimize angle between function a bit by removing, it's used by the particle system. Yeah, nothing else you need to say about it, right? Removing 2 length functions which each contain 1, 2, 1 square 2 length function calls, 2 redundant length function calls. There we go. This change optimize angle between function a bit by removing 2 redundant length function calls which each contain 1 square root, 2 multiplications, 1 addition. It is used by the particle system updates. Okay. Not measured because impacts will be immeasurable. I don't know how to type this. How to type this word? Immeasurable. God damn it. Did I type it correctly or not? Probably not. Yeah. Totally not. Immeasurable. Good. Will be practically immeasurable. Or let's say it will be measurable if you just execute it enough, but it will be too minor, let's say. Because impacts it's very minor. Expected. I'm not 100% sure, but I expected very minor. Okay. Good. I think that's good. Okay, cool. Then that in place. Let's see. Oh, we have a fail here. So, okay, so so greptile is happy, but the compiler is not happy. What is the problem? VC6. Oh, okay. Hash table. Is it the erase function? Yeah, which line is it? Oh, it doesn't tell us what the problem is. Hash compiling class template member function. hash table. Term does not evaluate to a function. Term does not evaluate to a function. I don't understand where the problem is exactly. I need a line that errors, please. I don't understand which function this is calling. This call, hash table. Struct, class. It's just a whole bunch of templating. What is this function here? Num key, what is this? I don't understand. Well, so it is failing to compile. Well, it's not good. I don't understand what the actual issue is there. Do STL for hash maps not store the container size? They do, but I don't care. Yeah, okay, so VC6 is failing. I don't know why. Let's check that next session. I will take a break now. Let's investigate next session. Good, then I will end it here. Take a break. I wish you a great day or night. Until next time. Goodbye.